Hello everyone, in this video we're going to create a snake game with Python and tkinter. First I'm going to explain the elements and the rules of the game, and then we're going to create it together with some basic Python code and a simple tkinter interface. With that said, let's get started. Okay, first of all, what is a snake game? It's a simple game where we control a snake that moves inside a grid. With the snake, there is also a piece of food that, when eaten, will increase the score and make the snake grow bigger. The game finishes when the snake hits a barrier or himself. Let's now move to the code. Create an empty project with an empty main.py. To make the code easier to understand, we're going to divide it into 5 sections: the game backbone, the grid, the snake, the food, and the score. Let's start with the game backbone. The first thing that we are going to do is create an empty interface, create an empty start game function, define start game, and call it at the end of the file. Start game. Now at the beginning import tkinter, from tkinter import star, and since we are already here, import random for later. Inside the game backbone, create a constant for the background color. Background color equals 0A, 0A, 0A. I decided to pick this color, but you can use the color you like. Now let's create the window. Window equals tk. Set the title, window.title, snake game. Make it non-resizable, window.resizable, false, false. And create an empty canvas variable. Canvas equals none. Now inside the start game function, let's create a new canvas. Global canvas to modify the outside variable. Canvas equals canvas window. Set the background color. bg equals background color. And for now, give the window a fixed size. Width 500, height 500. Canvas.pack to place the canvas, and window.mainLoop to start the interface. Now run the program. And as you can see, we have an empty interface. Now, this is a starting point, but what we want is not just an empty interface, but something like a grid, a snake that moves through the squares, etc. More in general, we want to have elements that evolve over time inside the interface. And to have that, we need to implement a game loop. So, what is a game loop? A game loop is, as the name suggests, a loop that is responsible for two things: update the state of the game and manage the internal time. In our case, we need a very simple game loop. We need to be able to update the elements of the game, like update the position of the snake, resolve collisions, draw the elements of the game on the interface, and wait for the next iteration. How long we wait between iterations will change how fast the game evolves. So we need to wait for a time that depends on the current speed of the game. Let's now move back to the code. We need to create a few functions. Define update elements. Define check collisions. Define draw elements. We are going to use these functions to update the state of the game, check for collisions, and redraw the elements inside the interface. For now, leave them empty. We will place some code later when we are going to implement the elements of the game. Now we can create the game loop function, but before that we need a few variables. We need to be able to check if the game is still running, and we can create a boolean variable for this. Is game running equals true. And we need to know the current speed of the game. For this we can use an integer number, game speed equals 3, where 3 stands for 3 game loop iterations per second. We can now create the game loop function, define game loop, call the update functions in the right order, update elements, check collisions, draw elements. Now, if the game is still running, if is game running, calculate the number of milliseconds to wait before the next iteration, update time equals int of 1000 divided by game speed, and call the next iteration with window.after update time game loop. Window.after will wait for the number of milliseconds calculated inside update time, and then we'll call the next iteration of game loop. Inside start game, after canvas.pack, call game loop to call the first iteration. Okay, with that we have finished creating the game loop, and we can start adding the components of our game. Let's start with the grid. We need 3 constants, grid color equals, which is the color of the grid in the game, grid size, which is the size of the grid in terms of horizontal and vertical squares, and square size equals 70, which is the size of each individual square in pixels. We can now set the right size of the interface with these constants, get back to the canvas definition inside the start game, and set width as grid size of 0 times square size, and height grid size of 1 times square size. With this, the size of the interface will adapt to the size of the grid. Now to draw the grid, we define a drawGrid function. Define drawGrid, global canvas, and define 2 helper variables. Canvas width equals grid size of 0 times square size, and canvas height equals grid size of 1 times square size. Inside this function, we are going to use the canvas.createLine function to draw the lines. This function takes as input the coordinates of the starting point, the coordinates of the end point, and the options, and automatically draws a line between the 2 points. To draw the vertical lines, we create a for loop for I x in range of grid size of 0, expose equals ix times square size, and for each iteration we draw a line with canvas dot create line expose 0, expose canvas height, width 1, fill grid color. With this we have created the vertical lines. For the horizontal lines we need to do the same thing for the other dimension. For I y in range of grid size of 1, y pose equals iy times square size, and we draw a line with canvas dot create line 0 y pose canvas width, y pose with 1, fill grid color. Now go inside the draw element function and add canvas.delete all to clear the previous frame and add draw grid to draw the grid. Start the program, and as you can see, the grid is now visible inside the interface. Let's now move to the snake. Set a constant for the snake color equals this color. We're going to represent the snake as a list of coordinates inside the grid. So snake coordinates equals 0, 0, 0, 0, 0, 0. We also need a next direction and a current direction variables. Declare next direction equals down and current direction equals down. So what is the meaning of these variables? Let's say that the snake is moving inside the grid. If you assign a coordinate to every grid square, we can represent the snake with a list of coordinates, where the first element is the position of the head and the last is the tail. The two directions next and current are instead used to control the snake. The current direction is the forward direction of the snake, so it's basically the direction the snake is currently facing. The next direction is a bit different. Since we want to control where the snake is going, this value is controlled by the player and is the direction of the next step of the snake. So if the current direction is right and the next direction is down, when the game gets an update, the snake will turn and start going down the grid. If the player tries to directly turn in the opposite direction, we can use these values to ignore the input and keep going forward until a different direction is selected. We need all three update functions for the snake, so let's start by declaring them. Define snake step, define draw snake, define check snake collisions. Let's start by implementing the step. We need to update two variables inside this function, global snake coordinates, to update the position of the snake, and current direction to keep it updated. Save the head of the snake in a variable, head equals snake coordinates of 0, and remove the tail of the snake. Snake coordinates equals snake coordinates from the beginning to index -1. Now we need to find where we need to place the new head of the snake. New head equals none. If next direction equals down, then new head equals head of 0, head of 1 plus 1. And if next direction equals up, new head equals head of 0, head of 1 minus 1. And if next direction equals left, then new head equals head of 0 minus 1, head of 1. And if next direction equals right, then new head equals head of 0 plus 1, head of 1. At this point, we only need to update the snake by inserting the new head into the snake coordinates with snake coordinates dot insert 0 new head, and update the current direction of the snake with current direction equals next direction. The update function is finished. Let's move to the draw snake function. Global canvas. Here we are going to use the canvas.createRectangle function to draw each individual square of the snake. This function is identical to canvas.drawLine, but this time, instead of drawing a line, it draws a square between the 2 points. For each block of the snake, for x, y in snake coordinates, compute the corners of the square. x1 equals x times square size, y1 equals y times square size, x2 equals x plus 1 times square size, and y2 equals y plus 1 times square size. Now draw the square with canvas.createRectangle, x1, y1, x2, y2, fill, snake color. To control the snake, declare a change direction function. Define change direction with parameter new direction. And outside the function, write window.bind left lambda event change direction left. So what is the meaning of this line? This line tells to the window that every time that the left arrow gets pressed, the game needs to call the change direction function with parameter left. And the function that we will implement in just a moment will update the direction of the snake. We need to do the same for the other directions. Window.bind right lambda event change direction right window.bind up lambda event change direction up, and window.bind down lambda event change direction down. Now moving to the change direction function. Global next direction equals new direction. Now this code is fine, but if we leave it as it is, the snake is able to turn in the complete opposite direction, which is something that we do not want. To fix this, add if new direction equals up and current direction equals down, or new direction equals down and current direction equals up, or new direction equals left and current direction equals right, or new direction equals right and current direction equals left, then return. By doing this, when the new direction is opposite to the current direction, we just return and ignore the input. The last thing that we are missing are the collisions. Get into check snake collisions. Global is game running. Save the head of the snake into a variable. Head equal snake coordinates of 0. Split the x and y values into two variables. Head of x equals head of 0, head of y equals head of 1. Do the same for the grid size. Grid size of x equals grid size of 0, grid size of y equals grid size of 1. Now the snake needs to stop the game in two cases. The first is when the snake hits a barrier, and the second is when the snake hits himself. To check if the snake hit a barrier, we check if head of x is less than 0, or head of x greater or equal grid size of x, or head of y is less than 0, or head of y greater or equal than grid size of y. Then is game running equals false. Now if the snake goes out of bounds, is game running becomes false and the game stops. To check if the snake has hit one of his blocks, we check if head in snake coordinates from index 1 to the end, then is game running equals false. And now the snake also stops if it hits himself. Now go into the update elements function. Add snake step. Inside the draw elements, add draw snake, and inside check collisions, check snake collisions. If we now run the game, we have a snake that moves inside the grid, and the game stops if we hit a barrier. This is everything for the snake. Let's move to the food. We need a constant for the color. Food color equals f1 to a00, and we need a variable to store the current position of the food. Food position equals 0, 0. Now the food is initially placed at the coordinates 0, 0, but what we want is to randomly place it inside the grid. To do that, inside the food section, define move food. This function is to randomly move the food inside the grid, so global food position, and we randomly assign new coordinates with new x equals random randint between 0 and grid size of 0 minus 1, and new y equals random dot randint between 0 grid size of 1 minus 1, and we assign the new position with food position equals new x, new y. This code is fine, but we are not considering one particular case. By randomly assigning the position, we risk that the new position is already inside the blocks of the snake. To fix this, we can check if food position in snake coordinates, then move food. By doing this, if the piece of food is already inside the blocks of the snake, we select a new random position. Outside the function, immediately call the move food function to randomly move it at the beginning of the game. Now we need to draw and check the collisions with the piece of food. Define check food collision and define draw food. Inside the check collision, save the head in a variable. Head equals snake coordinates of 0. And if the head of the snake matches the current position of the piece of food, if head equals food position, then move the food to a new position, move food, and increase the length of the snake by 1. Snake coordinates dot append snake coordinates of -1. To draw the piece of food, get the position of the corners. x1 equals food position of 0 times square size. y1 equals food position of 1 times square size. x2 equals food position of 0 plus 1 times square size, and y2 equals food position of 1 plus 1 times square size, and draw it with canvas dot create rectangle x1 y1 x2 y2 fill food color. Now inside check collisions, add check food collision, and inside draw elements add draw food. Now if we run the game, we have the snake that is moving, and the food moves every time the snake hits it. The game could be finished here, but we are going to add a few more things. First of all, we need a label to keep track of the current score of the player. Go inside the score section. Define a score variable to keep track of the current score. Score equals 0. Create the label for the interface. Label equals label window text equals score format score font consolas 40 label.pack, and define increase score function. Define increase score. The goal of this function is to increase the score of the player, so we need to update its value, global score. But every time we increase the score of the player, we also want to increase the speed of the game to make it more difficult. So we also need game speed. Inside the function, increase the score. Score equals score plus 1. Update the text inside the label. Label.config text equals score dot format score, and increase the speed of the game with game speed equals game speed plus 0.25. This function needs to be called every time the snake eats a piece of food, so move inside the check food collision function. And after move food, add the call increase score. Now we also want an end game screen, since for now when the player dies, the game stops and does nothing else. Go before the game loop function. And define a game over function. Define game over. When the player dies, we want to clear whatever is currently on the screen. So canvas.delete all. And we want to create a game over text for the player. Canvas width equals canvas.winfo underscore width, and canvas height equals canvas.winfo underscore height. To create the text, canvas.create text, canvas width divided by 2.0, canvas height divided by 2.0, text game over, font consolas 80, and fill F1 to A00. Now to call this function, get inside the game loop. When the game is no longer running, else call the game over function. Game over. And that's it. Now if you run the program, the game is complete. We can eat food, increase our score, the snake gets faster, and we also have an end screen at the end of the game. This is the end. This is a simple snake game with Python. I hope you learned something. If you want the code, you can check the GitHub repo in the description. I will also paste the code in the comments. Like and subscribe, this would mean a lot for the channel. Thank you for watching and see you next time.